Hello, everybody. Welcome back to another lecture from the Data Structures and Algorithms module. Today, we will continue our discussion of dynamic arrays from last time, and we will build from scratch in C++ a dynamic array. We will see the ins and outs of how to implement the various functions, and as we go along, we're also going to talk about complexity. Very quick reminder from last time, what are dynamic arrays? They're just like fixed size arrays, but they allow us to expand, to grow dynamically, to resize dynamically as elements are added. Reminder that dynamic arrays are called differently depending on the programming language you're working with. In C++, they're called vectors. And for the purposes of this course, I will just call them dynamic arrays. As we think about implementing dynamic arrays from scratch, assuming that they don't exist in C++ as vectors, what kind of things do we need to keep track of? Well, remember how a dynamic array structures. First, we have an underlying fixed size array. This one is going to be, in our case, an array of integers to make things a little bit simpler, and is going to be a pointer variable for the block of allocated memory. We're going to start with a fixed size array of size 1, just for simplicity, and then we're going to grow dynamically as we're entering more values into the dynamic array. Because fixed size arrays in C++, we're going to use a very primitive version, not the standard library version from C++, to not keep track of their size. We will have to keep track of the fixed size array capacity on our own. Capacity will, in a nutshell, mean how many slots are in total in the array. Not available slots, just how many slots in total can we store in this array. And finally, size is going to be another variable that will keep track of the elements stored, right? So size is always going to be less than or equal to the capacity. There are a couple of considerations that we should keep in mind. Again, we will make our fixed size array as a pointer variable to the block of memory. The array size we will keep completely separately and we'll call capacity. We will allocate the block of memory for the fixed size array using the keyword new. And every time that we need to resize dynamically, we're going to use the keyword delete to free memory that is not used anymore. The fixed size array itself cannot be resized, but what we're going to do is create a new larger block of memory, move the elements from the old block to the new block, and free the old block. We will call this function the growthful function, and I will come back to the slides to show you how we're doing that. So let's get started in C++. Please join me in VS Code. You will notice that I already have all of the implementation of my dynamic array, but I'm going to go ahead and delete it because I want us to build it from scratch together. So first things first, I want to make sure to include some libraries. I will need to make prints so that I can see how my array is changing size and I can see the elements in my array. So let's go ahead and include our IO stream. In addition to that, it's pretty standard in C++ to use the namespace standard so that we can call printing functions, cout, cin, and so on and so forth. So now that apologize, we need semicolon here, we have this, let's start to create our dynamic array completely from scratch. And I'll make this a little bit bigger so y'all can see. How am I going to store the dynamic array? When you learn about classes in the OOP module, you can have a class for the dynamic array. For the purposes of this course, we are going to use structs, both as a way for you to practice using structs, which are also similar to the C language, but also to start getting comfortable with creating struct-like objects so that when you go to the OOP module, you're more comfortable with that. So I'm going to call my class my dynamic array. I'm not going to call it vector because, as we said, a dynamic array vector exists in C++, so I'm just going to give it this name. And we will go ahead and create our first struct over here. As we are working with a dynamic array, I'm also going to have some space to test the functions. So let's create a main function here. And as we go along, I'm going to go ahead and make sure that we are testing the dynamic array functions. Okay, So now that I am inside my struct, what do I actually need to do? Well, we talked about the following portions, right? I need to make sure I have a fixed size array, I have the size, and I also have the capacity. Let's go ahead and create those. Those are generally called member variables because they belong to the struct. When you learn object-oriented programming, you will learn more why these member variables generally need to be private. But for now, just assume that we don't want people outside of the class, outside of the struct to be able to modify them. We only want to be able to modify them on our own. So we're going to declare them as private. And we're going to have three member variables. The first one is going to be the fixed size array, which is a pointer to the block of memory. So I'm going to call this fixed size array. I am going to have the capacity. I have to keep track of this manually. And I'm going to have also the size of the array, which is the current elements in the array. In the starter file that I gave you, I have quite a bit of comments that I consider part of the lectures and the material. For example, in this comment over here, I'm explaining just what I said, that we will keep these variables private to be able to modify them just within the struct. And here are the three things that the dynamic array needs to keep track of. So for simplicity, I'm going to copy some of those comments, but definitely do pay attention to them and read them carefully as assume as that they are part of the slides, right? But they come with the code base. So by default, in C++, structs, all the members are public, but we want to have those ones public to prevent other people from directly accessing our memory location or our capacity and modifying them. We will only allow people to modify these kinds of member variables via functions, right? And as I said in the OOP module, you're going to learn a little bit more about this. So this is going to be our fixed size array that will act as the dynamic array. This is a pointer to a block of memory. The capacity needs to be kept completely separately, right? Because fixed size arrays don't have capacity. And then this is going to be the number of elements. While I could hard code the starting value of the size of my dynamic array, for simplicity, let's actually not hard code it, but have a constant that will allow us to get started at a certain value. So here I'm going to declare a constant variable that's of type integer that tells me the value that the dynamic array is going to start at. Normally, we would want to start this at 100, right? So, or if I know that I'm going to have in the thousands of elements, I want to start at 1,000 at least, but I'm going to set this to 1 just to see how the array grows from 1 to 2 to 4 to 8 to 16, right? So this is going to be the initial capacity, much better than hard coding it into our creation. This is going to allow us to start at 1 and then grow dynamically from here. Okay, so these are the main parts of the struct, right? We want to create the struct dynamic array. We want to keep track of these three member variables, fixed size array, the capacity, and the size. And this one is just for simplicity, so we don't hard code. That, in a nutshell, wraps up our member variables. Now that we exactly know, right, what the dynamic array is going to look like, we can go ahead and create some constructors and destructors. Constructors and destructors are going to be used by us to allow us to create a new dynamic array and also open up space in memory when we don't want to have the dynamic array anymore, right? In C++, we have to keep track of memory locations on our own. So we have to have constructors and destructors. Again, when you take the OOP module, you're going to learn a little bit more in detail what constructors and destructors are. But let's go ahead, set them to public. Okay. The first constructor is going to be my dynamic array. This one is going to give specific values to the three members of the struct. What do I mean by that? My fixed size array is going to start as a new array of size 1, right? Let me break this down, what this is actually doing. And apologies, I mixed up the parentheses here. Okay, let's take 1. Okay, so I would like to initialize this fixed size array as an array of size 1 in memory. So here I'm claiming a memory location of size 1. Okay. I will go ahead and have the size starting at 0 because currently I don't have any elements in my array. And I'm going to go ahead and set my capacities the same as max entries, right? So right now, the maximum capacity I can hold is 1 element. Okay, so we call this a constructor. The constructor will initialize the size of the pointer array, the capacity, and the size of our array. And again, when you talk about the OOP module, you will learn a little bit more about constructors and destructors. Let's go ahead and create the destructor. We are going to use the tilde for the destructor that's standard in C++. And the part that I'm most concerned about is deleting this array, right? That's the one that is going to take the space. So I want to make sure that when my dynamic array is not being used anymore, I free up space of my fixed size array. Okay. Awesomeness. So now I have my constructor, I have my destructor, I have my member variables, and I can go ahead and do some testing. In my main method over here, I am going to go ahead and actually create a dynamic array. So I am going to create a dynamic array over here. I am going to call my constructor by saying, hey, call the dynamic array constructor, and can you please put the name of this dynamic array, array_din. Okay, let's go ahead and try to compile. Again, you can use the compiler up here if you set that up. For simplicity, I'm going to use my clang compiler from the terminal. So I will go ahead and call clang++ with my dynamic array CPP and my dynamic array. Maybe we have some errors. Let's take a look. It seems like everything compiled fine. If I try to run it for now, it also runs fine. We're currently not printing anything. That's totally okay. So that's why we don't see anything in the terminal, but we know it's compiling and running correctly so far. Awesome. So this was the first part of building our dynamic array. We got the 3 member variables, we got the constructor and destructors. Now let's start getting our hands dirty and building some functions, right? The first few functions are going to be relatively easy. I want to create a function that will check if my dynamic array is empty. Okay, so that function is going to return true or false. So the return type is going to be Boolean. I'm going to check by asking the class or the structure, the dynamic array, are you empty, right? So the name of the function is going to be empty. The way I'm going to check this is by checking if the size is equal to 0, right? And if that's true, I'm going to return true. Otherwise, if that is not true, I'm going to return false, right? So we are moving to building the various functions that will support the dynamic array. And the first function is the empty function, which returns a Boolean and checks if the size is equal to 0. In that case, it returns true. Otherwise, it returns false. Note, in C++, when we're working with functions that we know are not going to change the member variables of our struct. For example, if a function is working with a size, right, which is a member variable, or capacity, or fixed size array, when we know our function is going to work with them but not modify them, we can use the keyword const at the end of the function definition. This will indicate to C++ that this function is not going to modify the member variables, is a read-only function. Okay, so let's go ahead and save our class and test the empty. If we want to test if the empty is actually working, is as follows: is the dynamic array empty? Right, so I'm going to go ahead and use cout, which is the way that we print in C++, and I can check is that my dynamic array dot empty, right? Does that return 1 or 0 for me, which is true or false? In this case, the size is 0, so it should return false. Let's go ahead and compile. It compiled fine. Let's go ahead and run. And we got this that is true, right? The dynamic array currently is empty. The size is equal to 0 because we haven't added any elements. Let's go ahead and actually write another function. This is going to be the size function that will return the actual size, the number of elements in the array, right? So it's going to return an integer. We will call it size, and I am going to go ahead and return the size, right? Simply the size of elements. Again, because this is accessing a member variable and we're not making any changes to that member variable, we're going to keep it as a constant. If we were to go ahead and test this, what the size is, in this case, we should be able to get 0 because the size of the array currently is 0. There's no elements in it. Let's write a function that is called get that will get the elements at a given index. So I'm going to have an index as a parameter, and I want to go ahead and get that index. The first thing that I need to make sure is that that index is not out of bounds. If you remember, when we talked about fixed size arrays, the C-style array does not have bound checks, but the standard array has bound checks. The vector implementation of dynamic arrays in C++ also has bound checks. And it is a great practice to have safety in our code when it comes to accessing elements out of range, right? So the first thing is I'm going to check the index that the user gave me, is it an appropriate index? So if the index is greater than, right, or equal to the current size, that means that the user is trying to access an index that doesn't exist. So I'm going to go ahead and throw an out of range error that is going to tell the user index out of range. Okay. Otherwise, if I actually have the specific index, this is very easy. We can use indexing like this with the standard size array, right? So I'm going to go to my array and get that particular index, right? So this is the get function. Note, if I want this get function to also allow for modifying this value when it gets returned, right? So somebody returns this value and I want to modify it, right? If I want to return a modifiable reference, I can include this ampersand sign here. And that tells me that this get method can also work a little bit as a set method, right? So it's going to return a reference to that particular data index, and I can modify the value at that particular location. If I want to, I can totally separate those two functions. I can have a get function that is not modifiable, and I can have a set function that allows me to change the value of the element at the specific index, right? So for now, I'm going to leave the ampersand sign here. Let's go ahead and test this. Right now, if I am going to try to get an element at index 99, I should get an error, okay? Because we don't have an index at 99. The size is currently 0, right? So I'm going to go ahead and compile. And when I run, I'm going to get a termination due to a standard out of range. It's telling me that my index is out of range. So this is a runtime error. So it seems so far the first part of our get function is working correctly. We are missing this portion because we haven't added elements yet. Which brings me to the add function. So let's go ahead and write the add function. Whoops. Apologies about that. Let me, oh, I'm sorry. Okay, so for some reason I pressed my capital lock and I was looking for 99 here. Okay, so let's go ahead and create our add function. I'm going to return nothing. If I add an element, I could easily return a true or false if I wanted to, but in this case, I'm just adding an element. I am going to go ahead and make sure that this element is of type integer. And I can go ahead and call over here my fixed size array. And I'm going to say, hey, can you please go to whichever size you're at, put the element there, increment the size, right? and then be done with the function. So this is how traditional inserting into the dynamic array is going to look like, right? So this is my dynamic array here, right? And let's say that I have an element here, an element here, an element here, right? So the size is currently 3, right? Because I have 1, 2, 3 elements. So the size is currently 3. So basically what I'm saying, go ahead at index 3. So this is index 0, 1, 2, 3. Put this value into that particular index, right? And increment the size to now be 4. So the size, right, now it's actually 4. This is what this line of code is doing, setting the value at the next available location and incrementing the size. But you'll say, this works only when the array is not full, right? So what do we do when the array is full? We need to write the grow if full function. Okay, and we'll have to implement this function from scratch, and I'll do a quick reminder via the slides. But again, add to back is appending the given element at the end of the dynamic array. If there's no more space, we will first dynamically expand, and then if there is space, I'm going to insert the element at the end of the dynamic array. Let's go ahead to the slides to take a look at how the grow if full implementation will actually work, right? So from last time, we said that we are not changing the size of the fixed size array. That's not possible, but instead we're doubling the size of the array. We will copy each of the elements of the old array over. We will change the pointer to where the fixed size array is pointing to the new location in memory, and we will make sure to free up the old space in memory. Okay, so that is how our grow if full function is going to work. So let's repeat it one more time here. I am going to create a new space in memory, twice the size, copy the elements over, change the pointer, make sure to free up the space. Okay, so let's go ahead and implement together grow with full as a function. Now, the thing that I would like to mention is that traditionally functions like grow with full that only need to be used within the class or within the struct, and we don't want users outside of the struct to be able to use them, needs to be private. Okay, so I'm going to declare grow with full as private for now. And again, you'll learn more about public and private in the OOP module, but I do not want others to be able to use grow with full. Only I should be able to use grow with full within my class. Here are the steps that we said we will follow when working with grow with full. If the size of the array reaches capacity, we need to expand by getting a new block of memory first, copying the old block into the new block, and reclaiming the old block, right? So we have to go through each of those steps. Let's check when we reach capacity, right? So if the size of my array becomes bigger than or equal to my capacity, that means I'm at capacity, I need to expand. So in the case, I need to obtain a new block of memory that is going to be twice the size. So the new capacity is going to be twice the old capacity. Okay, and I need to get a new a new block amount of memory, new fixed size array, right? That is this new capacity, twice of the old one, right? So again, I'm going to use the new keyword here. Okay, so I check if I reach capacity. If I have, I double my capacity and I create a brand new block of memory that will have twice as many slots to store elements. So this was sort of process number 1. Now I'm going to go to process number 2. I need to copy the elements from the old array to the new array. So let's set up a for loop to do that. I am going to iterate from the 0th index of my current old array up to I reach the size. I don't need to iterate by the capacity if it's not necessary. I'm going to increment I, and what I will do here is that my new fixed size array, the element at location I, is going to be with a fixed size array element at location I, right? So here's where I am copying the elements. Whatever is in index I copy it over. Whatever is in index I copy it over. I'm going to change the capacity now to be the new capacity that I have here. Okay. I need to reclaim the block of memory that was of the old size array. So I need to go ahead and delete my fixed size array here. Okay, and now I'm going to go ahead and change the pointer of fixed size array, which is my member variable, to the new fixed size array. Okay, and that in a nutshell is the grow if full functionality. I check if I'm at capacity, create double the capacity, claim a block of memory twice the size, copy the old element over to the new array, change my capacity, reclaim the old space, change the pointer so that I'm pointing to the new element. Okay, so whenever I reach capacity, I am going to call grow full, and then I'm going to go ahead and insert the element into the new location. For us to be able to see a little bit how this is going to work, we will need to have a bunch of function calls here in main. But it's going to be easier if we have a way to print the elements of the array so we can see how things are changing. So let's create very quickly a print function, and then we're going to go ahead and test edge to back, which by default is going to test grow if full. Okay, so I want to be able to call a function every time I make a change to my dynamic array that I can see the elements separated one after the other. So let's call this print elements, right? Whatever you like. This is also going to be constant because I don't plan to change the elements. First, I want to print how many elements are in the dynamic array. So I'm going to say in this dynamic array, there are this many elements. So here I will put the size. Okay. And then I want to print out the capacity. So I'm going to also print the capacity here. Okay. And then in order for me to be able to print each individual element, I'm going to use a for loop that will iterate over my fixed size array and print the individual element. So let's go ahead and set up a for loop over here. And I am going to print the fixed size array of I, which is the current element. And I can use a comma or I can use a space. It doesn't really matter. Okay, so all that the print function is doing is printing the size, printing the capacity, and printing each of the elements of the fixed size array. This way, we will be able to test our code a little bit more easily. Okay, so let's go ahead here. First things first, let's test what the current dynamic array actually has. So I'm going to call print elements. Okay, so this is going to print that the dynamic array is currently empty, right? And there's no elements in it. Okay. And then let's go ahead and add a couple of elements, right? So over here, I am going to say I'm adding a new element. The element is going to be the value 30. Okay. I'm going to call my add to back. And I'm going to print my array elements to see what do I currently have in my array. Okay, so I create a dynamic array. When I print it, it should have a size of 0, capacity of 1, no elements. Then I'm going to insert 30. There should be a size of 1, a capacity of 1, and 30 in the array. Okay. Very quickly, let's save. Let's go ahead and compile. No errors. Let's go ahead and run it. And let's see what the output is, right? In the beginning, there are 0 elements in the dynamic array, capacity is 1 slot, and there's no elements printed. We add the new element. Now in the dynamic array, there are 1 element. Capacity is also 1 slot, and the value that I added is 30. Okay, so it seems like our add to back is working okay. Let's test the grow a full, right? So now if I want to insert another element, right? Let's say I want to insert element 20. Do I have any more space in the array? No, I don't, right? So when I call add to back, right? This is dynamically going to call grow full, is going to expand the size of the array, right? Our capacity now is not going to be 1 anymore, it's going to be 2. And then it's going to go ahead and put the element there. So let's go ahead and test this out as well. Okay, so compile, run. So here we saw that originally there was 1 element in the array and capacity was 1 slot, right? Now capacity increased to 2 slots, right? And there are 2 elements. So you saw how we dynamically incremented the space. Let's add another number. Now I want to add the third number. And again, we're going to have to dynamically grow because there's no space in the array. So let's go ahead, run, compile, right? So we see then in the second to last step, there were 2 elements and 2 slots, right? Now there are 4 slots. We jumped from 2 to 4. We increased our size. And now we have 3 elements because the third element is inserted. When I go ahead and insert another element, I don't need to change capacity yet because I still have a spot left. So I'm going to go ahead, add 1 more element to it, right? So let's run this. Now I still have 4 slots like I had before, right? But my array is of 4 elements. So if I wanted to go ahead and add a new element, you'll notice that the capacity is going to go from 4 to 8. So let's run it one more time. Now we see the capacity was 4, but because I want to add number 89, there's no more space here. I increase the capacity to 8. I insert 89, so now I have 1, 2, 3, 4, 5 elements in my array. Okay, so our grow full is working correctly. Our edge to back is also working correctly. Feel free to get your hands dirty with this code, insert more elements and see how they're working. But in a nutshell, what we were doing here is actually working. Let's go ahead and write some more functions. I am going to write the function remove last. So I was able to insert at the back. Now I'm going to remove from the back. Generally, we do not shrink once the array has expanded, so we don't do that. And for the purposes of this class, we will keep that tradition. Instead, I am just going to decrement the size, right? So here I'm going to check, hey, if I, by mistake, have an empty array and I'm also trying to remove a last element, I'm going to throw an error out of range, where I'm going to say, cannot remove from an empty dynamic array. Okay, so this is again just a safety feature for us so that if a user is trying to remove when the array is empty, they can't do that. Otherwise, I am simply going to decrement the size, right? I do not worry about deleting the integer because if I end up incrementing the size again, I will overwrite whatever value was there, right? So I want to make sure I decrement the size. So let's go ahead and test this a little bit more over here. We are down here at 89. Let's remove the last element and then print the array. So over here, I'm going to go ahead and remove the last element. So the array will have 30, 20, 10, 5. And if we compile and then run, 30, 20, 10, 5, right? We do not change the size of the array, but we change the size of the elements. Let's go ahead and remove one more time. Now we will see 5 getting removed, right? So now we have 30, 20, 10. So that is how remove last actually works. In a nutshell, today we were able to cover the implementation of a dynamic array from scratch. What I showed you here was how to create the member variables of our dynamic array, how to initialize them in the constructor, and how to open up space, how to write functions such as empty, size, and get, how to write functions like add to back, print elements, or remove last. What I will leave for you as exercise is to write the following 2 functions. First, I'd like you to write the function find. The way that find is going to work is iterate through the array to look for, or through the dynamic array to look for a specific element. So it's going to take a number or a target as a starting point and is going to iterate through the array to figure out whether the element is in the array or not. So it's going to return the index if the value is there, or is going to return -1 if the element is not in the array. So return index of element if found, or -1 if not found. Okay, so I will leave this for you as an exercise, and once you try it out on your own, come back to the file solutions to compare your solution with that. In addition to that, I would like you to try to write another function, which is going to be called remove element. This function is going to also take a given target as an element, and it will try to remove that particular element. First, it needs to figure out, is the element there? To do that, you can use the find function that we implemented above. So if the element is there, what you need to do is remove an element. This will require some shifting, right? So if I'm removing an element that exists in the middle, I need to shift all of the values forward, right? So this function will remove an element at a given index and will shift every element after it forward. So if I'm removing the element at the 0th location, all of the n-1 elements have to shift over, right? So I'll give you a little bit the algorithm here. Find the element first, right? If you find it, go ahead and shift from the current index all the way to the back, right? So you're going to shift, if you delete this element, you're going to shift this way, right? So you're shifting towards the front of the array, starting from index, decrement the size of the array, right? And then you're done. You return true if the element was erased. If the element is not found. Okay, so give this again a try on your own, and once you have a solution, come back to the solution files to test if it's working correctly. I will also note that the solution file has many more tests that I have implemented. Use those as you are testing the functionality of your find function and remove element functions. That is all in a nutshell for the lecture today. Thank you for joining me in building a dynamic array from scratch. The best way to practice with these kinds of skills is first to understand conceptually how dynamic arrays work, what their properties are. Second, to read through the comments in the file that I have provided for you to truly understand what each function or each component of the file is doing. And three, the best way to practice is deleting the whole file and starting to implement it from scratch to truly see if you've understood how each of the individual elements of the structure and the functions work. Thank you for joining me today, and I will see you in the next lecture.